two. Or these four, I guess. First things first, I think the first question was, what color is Mr. Kenny's hair?
Brown.
Okay. Regardless of whether you know the answer or not, first off, is it numerical data what type of hair I have? No. There is no number. What are the kind of responses you can get for hair color?
Oh, purple. Oh, black.
Green.
All color. Orange,
Black.
blue, different things like that.
Yellow.
So,
Gray.
turquoise. Stop. Okay. You go next. Just stop. Okay? So no matter what though, is that a numerical value? No. That's fitting into a category. Hopefully we know the difference between categorical and numerical, because you will be having a quiz later this week, probably on Friday, because we have gone too long without some form of assessment, but it's not numerical. I heard someone already adamantly saying, hey, that is a statistical question. Who says statistical, or non-statistical is what I meant to say. Okay, raise your hand if you think it's non-statistical. I want to hear from someone I don't usually hear from. Ireland, why do you think it's non-statistical? Terrence, let her talk. You don't need to keep mumbling. I'll catch it on camera and I'll watch it tonight.
You right.
Ireland, why do you say it is non-statistical? Not sure? Because what?
I'm guessing because it says what color instead of how many.
Okay, does that explain why it's non-statistical or why it's categorical or numerical?
I don't know.
So is that about the type of data or is that about the type of question? That's about the type of data, right? What you got?
It doesn't vary.
Yeah, does my hair color vary?
No.
I mean, y'all might disagree on what my hair color is, but no matter what, my hair color stays the same.
I think it's
I mean,
brown.
unless you change it.
It's
I
brown.
mean, I'm not, though.
Hey, Terrence, why you cheating, bro?
Dude.
I'm just saying. So we want to cheat on.
Okay.
You don't want
She ain't cheating on you. What's she pregnant?
So,
Hey, lady.
what was I going to say? No, my hair color does not change. People have had different opinions. Some
Is it
people
brown?
think it's black. Some people think it's a dark brown. Okay. Regardless, does my hair color change?
No.
Yes. Well, I mean,
Orange.
Orange.
Yes, mine.
No.
no. Wait, yes, it do because when you get out, it turns gray.
If someone is surveying right now or asking the question today,
Oh, yeah.
what color is Mr. Kenny's hair color?
Black.
Brown.
I'm going to go I'm okay with either one. But here's the thing. Does my hair change within the next 5 seconds?
Nah.
So there is no variability in the response. Okay? Hannah should have picked a different question, but it does not change. If there's no variability, it is non-statistical.
Oh, yes, sir.
Okay? Also, I will point this out. Hey, listen. If you are collecting responses about one single thing, that's going to be non-statistical. Because if you're only collecting data about one thing, can there be variability?
Yes. No, my bad.
No. Remember, it is non-statistical if there is no variability. If you're only collecting data or responses about one thing, there can't be variability. All right? Next question. A little bit more uniform on this one. The type, what is a typical number of states students in this class have visited? We got a handful who thought categorical.
Come on, say it's different place.
It does talk about different states, right?
But it's numerical.
But it's statistical.
But it says how many, right? Please hear me very clearly on that. Can the individual states fall under different categories? Yeah, Alabama is different than Louisiana. However, the question is not which states, it's the number. How many states, right? So is that numerical or categorical? That's numerical, right? And remember, listen, it's all about the response. Kaylin, if I need to take the box away from you so you aren't distracted by it, I will. You're distracting me and the others of your group because you keep opening and closing it. Quit. Pay attention. So, if you were to ask someone how many states have you visited, they would give you a numerical value back. Correct? Yes? Alright. Let's move on from there. Oh, statistical or non-statistical? Why is it statistical? Anton, where's your group?
I mean, sir.
Where's your group? Yeah, face forward. There's a reason why those desks are face forward. Yeah, face forward. So, will the response vary from student to student to student? 100%, right? So, because those responses vary, we are looking at a statistical question. Now, we are all over the place on this one. Let n equal 5 and p equal -2. What is the value of p squared minus 5n equals -3? I went ahead and chose a couple of people. Hold on. Austin, what'd you get for this answer?
D.
Which one? D? This one?
Yeah.
Yeah? How'd you approach this problem?
I substituted and then
What'd you substitute?
whatever I say that I can't read that.
So n is equal to 5 and p is equal to -2.
I substituted. I don't know.
Not sure?
I did it. I don't know how to explain it.
Okay. Zaria, can you tell us what you did? First off, did you get D?
I got B.
You got B, okay? So we're gonna look at B now. So Zaria, how did you approach this problem?
I did -2 squared minus 5 times 5 divided by -2.
Minus 5 times 5 divided by -3 because it was p squared minus 5n divided by -3, okay? Is that exactly how you wrote it? Does anybody see a mistake that might make?
No.
You corrected me on it, so if it's a mistake.
No, I corrected the 5 times 5. There's another mistake.
Would you put, parentheses in it?
What is it two negatives right there? Or is it
So
negative?
notice how p is a -2. If you work it out this way right now, and you plug this into a calculator, you're gonna get -4
You gotta have a
minus 25. Hold on one second. Divided by -3, which gives you, note, a -29 divided by -3. Hold on. So Zaria, if you worked out this way, you would have got -29 divided by -3. Now, because it is two negatives, what would you get, Austin?
Positive.
A positive, right? That's where Austin's getting a positive 29/3. That's why, but Zaria's getting a negative 29/3. But what is the mistake? What were we gonna say with this, Josh? Weren't you trying to say something?
I said.
Oh, Gabe was trying to say something. What's up? Okay, am I
Around
just
the negative
squaring the 2?
Yeah.
Yes.
Just the 2?
No,
Just
the round
the
of
two?
fives too, the whole, you gotta do all that.
Negative.
I'm squaring the -2,
Yeah.
right? And this is an important distinction. If you miss that, that's okay, but that's something you need to correct, pay attention to, store in your memory, write it down somewhere. But, Zari, notice how we're squaring p? So I'm squaring the entire -2. If you put just -2 squared in your calculator, you get -4. But if I do -2 squared, that is -2 times -2, which is a positive 4. And then, so that's a positive 4 minus 25. So it's a negative 21. And what's negative 21 divided by -3? Positive 7.
Okay, this big game.
Okay. For anyone who got it wrong, do we want to ask any questions, or does that make sense how to fix it?
I need to do this.
We got it.
You good? Okay. Hey, please listen very clearly. It is great to make mistakes. When you make mistakes, that is a chance to learn and to grow. So investigate those mistakes, be comfortable with them, ask questions about them. Just be willing to be wrong. That's one of the biggest things for a lot of students, is we're so scared of being wrong that we miss out on the chances to grow. And it doesn't matter where you've been, it matters where you're going. Alright? So make sure you're asking those questions. Matthew, do you have a question or statement? Huh?
Are you counting them? Grading these?
No, the whole point of this is to learn and to grow. Would it be fair to count these if you're still learning? No, that's silly, right?
Participate.
Right.
Why would I give you a participation grade? You're in high school. You're not in elementary school and middle school.
But we participate.
Good job. That's what you're supposed to do. If you don't participate, are you going to learn?
Yeah, but they won't motivate us to participate. If you don't report.
Hold up. And I'll go ahead and tell you, anyone who's had my class before can tell you, you have to participate in order to grow and learn. If you don't participate, those quizzes and those tests are going to be rough.
So what if you just listening?
Then hopefully you can learn well enough. You can learn well enough just by listening. But I am telling you right here and right now, those who participate will learn more and be more successful in my class. So, it's your choice. I'm not going to give you points for participating. That's what you're supposed to do, right? That's like giving someone a reward for not going to jail. No, you're not supposed to go to jail, so I'm not going to give you a reward for doing what you're supposed to do. Does that make sense? Okay? I guess. Regardless, what I need you to understand is, I'm telling you this because I care about you and I need you to do these things so that you can learn. Alright? Last question. Only a handful of us got false here, but only a handful of us answered it. A little over half of us.
Please excuse this interruption. We need to see Dynasty Dixon for a few minutes.
She's on her way.
Thank you.
Yes, ma'am. Alright, so the statement is the value of 3 is a solution for the equation n squared minus 5 equals 4. Alright? Kyson, I already told you I was going to come and ask you about this one. Right? Did you say this was true or false?
I guess.
You guessed it.
True.
I know.
Why'd you guess it? You didn't know?
I know answer.
Did you try asking some questions or figuring out, looking at your notes? Okay, this is another note. Remember, I already told y'all based on my juniors and seniors what not to do with homework of the whole, cheating thing and copying off of others. Here's a hint of what to do on homework. That homework is directly built off of the lessons we have in class. Can you go look at your notes from class to help you on homework?
Yeah.
Could you pull out your notes right now to help you with bell ringers?
Yeah.
Yes. Okay? This is why you need to participate so that you have notes that you can look at. Yes, ma'am.
How did you know
What?
that they copied them?
Oh, it's literally the exact same wording. Remember, you have to justify your answers, 1. And so when you have a sentence that is identical to someone else, it's really easy to catch. 2, when you make the same silly mistake as someone else and it's written exactly the same way, it's really easy to catch.
Oh, they
So they both
should
got
have
it wrong.
reworded this song, because that's what I would do.
I know, if you're going to cheat, at least cheat well, right? But they didn't, okay? So it was really easy to catch them. But regardless, it's very honestly easy to catch someone cheating when you have them explain and justify their answers. It really is. So even though it's multiple choice, you have to explain your answers. You can't score well if you don't explain your answers. Alright? And it's not a punishment, it's a way to help you get better. So, Kyson, if you weren't sure how to do this, you should probably pick your head up, look at the board, and make sure you're paying attention. I have a lot of people who said true. Anyone want to explain why? Let's get someone who hasn't shared yet. Josh, you haven't shared anything yet, have you?
Yeah.
What'd you share earlier?
It was, what do you call it? The first one.
Oh, was it the first one? Okay. Someone who hasn't shared yet. Gabe, I haven't called on you yet? Okay, Gabe, what you got on this one?
I got true.
You got true, but why did you get true?
Because you gotta put parentheses around the 3.
Because you got a what?
You gotta put parentheses around the 3, the positive 3.
Okay, so just,
3.
there it is, that's it?
No. Oh, my bad. So you gotta put parentheses around the positive 3, and then 2 is the exponent.
Okay, so the exponent of 2 goes on the 3?
Then minus 5 equals 4.
Okay, really quickly, what is the language that we should use here for what Gabe just did?
Substitute.
He substituted, right? He substituted that 3 in for n. Because we're asking, is it a solution? Now what should I do? Square it, which gives me 9. So 9 minus 5 is?
4.
How do we know that 3 is a solution?
Because the same is true.
A solution, you got to go back to this. This is a part of your homework. This is number 8 on your homework. A solution will make the mathematical statement true. Does that make the statement true? So it's a solution. You good with that, Kaisen? Are you even, have you looked at the board since we substituted stuff in? Okay. Anton? You got it? Let's get started with today's lesson. Alright, we already have lesson 6 in our notebook that we can get out, correct? Yes, thank you. Let's get lesson 6 out of our notebook to work today. I would keep your lesson 6 homework out because you'll have chances to ask questions after we finish the lesson 6 today. Okay? Terrence, it helps to learn. We got your head up, buddy. Because, yeah, if you ever want stuff to wipe off the desk.
Please excuse this interruption. We need Gabe Davenport for checkout.
He is on his way. Gabe, I'm going to finish recording the lesson, so make sure you check out YouTube or come to tutoring, ask questions, things like that. Yes, ma'am. Can you what? It didn't fall out of your backpack, you accidentally left it. Alright. So here's our agenda for today. No, apparently forgot to update that. We're just getting back to the lesson 6. Alright, so I'll be honest, I have no clue who I asked to read objectives yesterday. I need to start using some kind of randomizer. Let's see. Jeremy, can you read our first objective for us?
I can tell whether two expressions are equivalent and explain why or not.
Okay, I can tell whether two expressions are equivalent, explain why or why not. That's huge. Terrence, can you read our second objective for us, please? Man, that dude is out cold. Never mind. Try to wake him up so he can learn something later. Amari, can you read our second objective, please? You don't know how to read?
I know how to read, but I don't want to do that.
I didn't ask, come on. Actually, I did technically ask, but come on, read it for us. The second one right here. So I... Alright, so I know and can identify the moves that can be made to transform an equation to an equivalent one. And Brooke, can you read our last one for us, please?
I understand what it means for two equations to be equivalent and how equivalent equations can be used to describe the same situation in different ways.
Okay. So I want to point this out. Alright? We discussed this yesterday. What is the key word that keeps popping up in each of these objectives? Equivalent, right? Does equivalent mean equal?
No.
Definitely not, right? We need to be aware of that. How did we define equivalent expressions yesterday? We should have it on our notes from when we looked at these problems.
That look different are effectively the same.
Okay, we said that these two expressions, did they look the same? No. But they look different, or so they look different, but they're still effectively the same. Alright? We can usually figure that out by simplifying. For example, I didn't show you this yesterday, but if I look at n squared minus 9 divided by 2 times 4 minus 3. Can I do 2 times 4 and 2 times negative 3? Yeah, what's that called? Distribution, right? The distributive property. So that would give me 2 times 4 minus 2 times 3, or 3 times 2. Okay, what's 2 times 4?
8.
8. Hey, notice how these denominators are literally the same thing? Right? 8 minus 3 times 2, and 8 minus 3 times 2. All I did was simplify them. Those denominators are exactly the same thing. Notice I'm looking at this first expression. Based on the numerator, any guesses what n plus 3 times n minus 3 might be? You don't need to know, you don't know how to do that quite yet, but any guesses what n plus 3 times n minus 3 would need to be according to this expression? Remember, I said these denominators are the same. So what does n plus 3 times n minus 3 need to be the same as? The denominator is already the same.
Oh, okay. Well,
The numerator. You don't know how to do that yet, that's fine, but I want you to notice n plus 3 times n minus 3 is n squared minus 9. That's why they're equivalent. They look different, but if you rewrite them using properties, they're exactly the same expression. Okay? And so they look different, but they're effectively the same. And so we started here, much ado about ages. We didn't talk about this one at all, I just had y'all working, correct? Does that sound correct for everybody? Alright. Let's start here. Let's go ahead and go over A then, and then I'll let you work on B and number 2 as well. So in family A, the youngest child is 7 years younger than the oldest, who is 18. What is an equation that we can put for A? Rose?
7 plus x equals 18.
Say it one more time.
7 plus x equals 18.
no, that's
Sound.
So if I take 7 and I add the age of the youngest child, will I get 18? The age of the oldest child? Anybody come up with a different equation? What you got, Brooke?
18 minus 7 equals 1.
So 18 minus 7 is equal to y. Just so we keep the same variable, let's say x. It doesn't matter. It can be any variable you want. So what does this say?
18 minus.
18 minus 7 equals 18.
Okay, 2 quick things, right? 18 minus 7, yes, but in the context of this problem, what is that 18 representing? The age of the oldest child minus their years apart, right? So if I take the age of the oldest child and I take away the ages that they're apart, I get the age of the, is it middle or youngest? Younger child. Middle child doesn't come out up till part B. Any other equations that someone came up with? Let me ask you this. If I take the age of the oldest child and I take away the age of the youngest child, anyone know what that's going to be? It equals 7, right?
Yeah.
Because isn't this just representing how far apart they are? Are these the same equations?
Wait, so
Do they look exactly the same? Let me clarify. No. Are they telling the same story though?
Yes.
So what do you think we would call those?
Equivalent equation.
Equivalent equations. We're going to talk more about what moves we can use to go from one equation to the next. But it's important to notice these equivalent equations look different, but they tell the same story. They look different, but they tell the same story. I'll answer Dee Dee's question, and then I want us to start working within our groups. Yes, ma'am.
Okay, so what if you use like, okay, if you use the youngest child age and then you put it with the little 7 or whatever and then get the 18 or whatever. Like 11 plus 7 because it was 11 and then plus 7.
Well, but remember, so we now know that the child's age is 11. Did we know that when we started?
Okay.
No.
That's the whole point of why we're using a variable, is to represent something we didn't originally know. Okay? Now, I do want to point this out, because students in even my Algebra 2 class missed this. Are the children in family B the same as the children in family A? No. No. They're 2 different families. Okay? Please notice it says the middle child is 5 years older than the youngest child. Do you know the age of the middle child?
No.
Do you know the age of the youngest child?
Yes.
How old is it?
I think it was
7.
Wait, 7.
Oh, you somebody in
Notice
and B?
B is different. Do we know the age of the youngest?
No.
No. So what are we going to have to use to represent both of those ideas? The same variable?
No.
Why not the same variable?
Because 2 different families.
Because they're 2 different. We're looking at family B now.
Only for a while.
Oh.
Why does it need to be 2 different variables?
Because they're 2
different kids.
It's 2 different kids. Are those kids going to have the same age?
No.
No. One's older than the other, right? Youngest and middle. So we need two different variables here. We need to pay attention to that while we're trying to create our equations. So, this will be a little bit harder. Not terribly, but you're going to have to play around with it probably to figure this out, right? The middle child is 5 years older than the youngest child. So what can you do to relate those two ideas? Talk within your groups. I'll be coming around checking on you. Try to wake those up who are asleep. Man, what is Ireland? You did not need to pull that boy's hair. Come on now. But wake them up so they can learn. There we go. Thank you. All right, let's get to work.